All right, in this video we're going to do a couple of word problems involving exponential functions and maybe logarithms. We'll see. Now, these equations, these formulas will be given to you. So you don't have to memorize them. But you do have to know which one does what. Okay? So let's see. The initial population of a small city is 40,500. Population is decreasing by a rate of 2% per year. When will the population reach 20,000 people? So which one of these formulas do you think we're going to use?
The last one.
The last one. Okay? The first two formulas are for compound interest. So this is clearly not a compound interest problem. This is just a basic exponential reduction problem. Because it's getting less, we use the one with the minus in it. So 1 minus r, okay? So with that in mind, the formula will be y equals. So the initial population was 40,000. 500. I'm hesitating because we want to know when the population will reach 20,000. So we should go ahead and put the 20,000 right in the front. Okay? Because we know that that's going to be the answer. We started from 40,500. And then we had that 1 minus the rate. Now the rate being 2%, am I going to put a 2 right here?
No.
I put 0.02. And then to the power of time. Okay? Got to divide both sides by 40,500. Help me out. What is that? 0.49 exactly?
No, 0.49.
Give me a fraction. Give me a fraction then.
40 over 81.
40 over 81? Okay, so if you put this in your calculator, it reduces to 40 over 81. So I'm going to use that.
Gotta take out like half.
Okay, so 40 over 81 is equal to, what's 1 minus 0.02?
0.98.
0.98?
Yeah, right.
So if I were you, I'd go ahead and write 0.98 instead of writing 1 minus 0.02. So 0.98 to the t power. So that's all we can do as far as the algebra steps. So we will write this in the other form. Always start with your base. So in the other form, so I'll have my 0.9, no. I'm writing log form, so I need to write log. So I'll have log 0.98. And the other two things have to switch sides. So the t is going to come over here, and the 40 over 81 is going to come over here. So you can just put this in your calculator. No, you can't. You have to use the change of base formula to put this in your calculator. So remember, we have to do log of 40 over 81. It's going to be like this. Fraction mode. We'll do log of 40 over 81 in the top. Oh. Multi-fail. Okay. What? And in the bottom, what's left?
What was it?
0.98.
There it goes.
Okay, that's how you put it in your calculator. So we get 34.92.
For 35 years.
Don't round that much.
You're gonna put 34.92 years.
Mm-hmm.
Okay. 20.
So number 26. You want to quadruple your initial investment in 8 years. What does that mean? Quadruple. Quadruple?
4 times.
Thank you, man. Y'all were scaring me with your general knowledge of like English, I guess. Quadruple means like you want it to be 4 times as much as you have. Boom. Yesterday someone was asking me, well, wait, how much are we starting with? It doesn't matter. You can pick any number. Don't talk to Peter. Coop. He's not even supposed to be sitting over there. Go back to your seat, Peter. So, continuously. Which formula do we use for compounded continuously? The second one. PERT. That's the compounding continuously formula. Okay? So you have to know which formula is which. So that's what we're going to do. I'm just going to make up a number. I'm going to say $1,000. $1,000 is my initial investment. And then it's E. They want to know the rate, so obviously I don't know the rate yet. 8 years is the time, so I'll put 8R up there. If I wanted to quadruple, how much will I have eventually? Right, if I have 1,000, I'll have 4,000. So I just need to solve this for R. Okay. Oh, is it going to lag every single time? Okay, so I guess we're doing this now.
Oh gosh.
This is awful. So this is going to give me 4, of course. That's the quadruple that we were speaking of.
That's sweet. Good job.
Okay. So this is the point at which we have to switch to the other form. So normally I would write log base E, right? Because you always got to start with the base. But we know that base E is really ln, natural log. So watch out for that. These other two things, the 8R and the 4, have to switch sides. In fact, it's going to bother me. Alright, so I had the base over here. So I have log base E. The 8R is going to come over here, and the 4 is going to come over there. So that means, no, it's not lagging now, yay. So that's natural log 4. Alright, so all I have to do is divide both sides by 8, and I'm good. It changed colors in the middle. That's crazy. Mr. Burton, you're crazy. So you just put that in your calculator. Natural log 4 over 8. 0.17. You're at 0.1733. The reason why I put that many decimals is because we don't leave it like this. Rate we convert over to a percent. So after we convert it to a percent, I still want to have 2 decimal places left. So what will this be as a percent, obviously? 17.33%. That's the rate we would need to quadruple our money in 8 years. All right, number 27. What interest rate compounded continuously is required for a $10,000 investment to grow to $14,500 in 5 years? Well, what formula do we use when it says, right, we're using this PERT 1, all right there. So if we want this much money, then that's what we have to start with. 14,500 equals 10,000 E, and I'm going to put 5R like that. Any questions right there? The setup. So then we'll divide both sides by 10,000.
Sorry for what?
All right. What do we get when we divide it by 10,000 here? 29 over 20. Okay, is equal to E to the 5R power. So that's when we have to switch it over to the other form, log form. So this would be log base E. The 5R goes to the left, the fraction goes to the right. So Over here I'll have 5r. And over here I'll have that 29 over 20.
You get the same answer if you put the fraction as a decimal.
Are you rounding?
No, it'd be 1.45.
Yeah.
Okay, then that's totally fine. 29 over 20. Okay. And then I'm going to divide both sides by 5. And that should be my answer. Alright, so natural log 29 over 20. This was divided by 5, yeah? So we get this 0.0743. All right, so that's 7.43%. And number 28, you invest $5,000 at 6.5% interest compounded daily. How long will it take for the investment to reach $20,000? So first we have to decide which formula we're going to use. These are the formulas that we sort of choose from. This is the formula that we use when we have interest that's being compounded and we're given a certain amount of time, whether it's daily, monthly, quarterly, something like that. Remember that this is the one we use for, whoops, okay, that was a fail. This is the one that we use for continuously. But this is the one that we use when it's daily, monthly, quarterly, etc. And this n value has to do with how many times a year we are compounding. So if we compound monthly, for example, that means that n is 12, because that means 12 times a year. If we do it daily, then n is going to equal 365 days a year. And if we do quarterly, then n is equal to 4, because quarterly is 4 times a year. Okay, so we're doing daily. So as we set this up, we want the investment to reach $20,000. Now looking at this formula, this A is the amount that we're going to have after time goes by. So we want this A to be 20,000. That's why I'm going to put 20,000 in for A. So I'll have 20,000 equals. Okay, now this P is the original amount. So that's our $5,000 investment. Alright, I apologize for the sound of my voice. I'm sick. I shouldn't say I'm getting sick. I am sick. But I'm just going to tough it out. I'm a big boy. So I have R over N. Alright, R is going to be the rate converted to a decimal. So this will change to 0.065. Okay, so 0.065 over N. Because it says daily, that means N is going to equal 365. Okay, and then it says to the NT power. So again, there's your 365. And then T, we don't know. We're supposed to find out how long. We're looking for the number of years. So this is the equation we need to solve it. So we will solve it by dividing both sides by 5,000. Alright, that'll be our first step. Alright, using a little of mental math, these are both in thousands, so we can sort of disregard the zeros. We've got 20 divided by 5, so obviously that's 4. So that gives us 4 equals 1 plus 0.065 over 365 to the 365 t power. So that's as far as we can go using our old algebra skills. To get any further, we need to rewrite this in log form. Alright, so this is pretty ugly, but we can do it. When you write log form, always start with the base. So this is the base right here. So we're going to start by writing log base this. Alright, and I recommend not converting this to a decimal. I know it's going to be a little ugly, but you're going to lose too much information if you try to turn this into a decimal. So we're going to write log base this. Okay, so we're going to have log base 1 plus 0.065 over 365. Okay, so that was the base. Now these other two things have to switch sides. So the 365t is going to come to the left, and the 4 is going to come to the right. So that's why I will have my 365t over here, and the 4 is going to be over here. Alright, so we're trying to get t by itself. So to get that, we need to divide both sides by 365. Alright, so that's going to give us the answer. So we just have to evaluate this. We'll start with the numerator. Remember, to put this into our TI-30, we'll have to use the change of base formula, and we'll have to do the log of 4 over the log of this stuff. So that's what I'm about to do right now. So let's do that. So let's do fraction mode, and we'll do the log of 4, and then we'll do over the log of 1 plus 0.065 over 365. Okay, so we get this. Now don't round this. So far we've evaluated the blue part. Now we just need to divide by 365. So leaving this in the calculator, we can just hit divided by 365. Yeah. Okay, so that gives us the answer. So this is 21.33 years. So that's how long it will take. Alright, let's do one more of these word problems. You want to have $2,500 after 4 years. Find the amount that you should deposit if the account pays 2.25% annual interest and is compounded quarterly. So this is another one where we're going to use this formula. Okay, whenever they mention how often they're compounding, this is the formula that we use. And for quarterly, n is 4. Alright, so if we want to have $2,500 eventually, then that's the A value. Alright, so I'll put my 2,500 first. Okay, then we put the P is the initial amount. So they're asking, find the amount you should deposit. So that's the P. We don't know it. And now we have the rest of it. 1 plus R over N. Okay, so that's 1 plus, the rate is 2.25%. If we convert that to a decimal, that's 0.025. Okay, now down here is N. We're compounding quarterly, so N is 4. And then it's NT power. Okay, so that's 4, and the time is 4 years. So that's another 4. Okay, that's two different things though. The first 4 is N, quarterly. The second 4 is because it was 4 years. So we have to solve this for P. So, if we want to get P by itself, basically, we need to divide both sides by this stuff. So I'm going to divide by 1 plus 0.025 over 4, and this is 16. Alright, I'm dividing by this. Okay, that way all this cancels out, and that'll just leave P. So this will give us the answer. So it's just a matter of putting this in the calculator. So fraction mode, 2,500, and then in the denominator we have this. So 1 plus 0.025. Over 4, and then to the 16th power. So there's my 4, and then there's my 16th power. Alright, so $2,262.80. Got to round up a little bit.